Good morning students. So today we are going to see the concept of Unit 3 in Artificial Intelligence. Unit 3 topic is Python library. So already Unit 2 we will saw the examples, what is a Python and what are the examples, arithmetic operation, regression function and list tuples and all. So now we are going to use what are the libraries you are going to use in the Python language. So introduction part, virtualization, all those things, indexing, multi-dimensional ND array, all those things comes under the unit 3 topics. So the introduction of NumPy multi-dimensional. So what is the meaning of NumPy? NumPy is numerical Python. Is a powerful Python library used for numerical computing, especially when working the large multi-dimensional arrays and matrix. Array is nothing but you can get the example of 0, 1, 2, 3, 4, right? So these are the array elements. How we are going to find out in the mathematical Python? How we are going to solve? So first you can install the library as a NumPy. NumPy is one of the library. You can use it in the Anaconda or MATLAB library also. Okay, so you can install NumPy and pin the install to the NumPy, import the NumPy as a Python. So now all those things you can done in the Google Colab itself. So now we can solve the first example. That's the first topic of the NumPy is multi-dimensional array in NumPy, using the NumPy. So first you can import the NumPy. Okay, so 1D, 2D, 3D. So totally we have the dimensional array, mean you can consider as a 1D array, 2D array, 3D array. So 1D array you can take an example. First you can import the NumPy and as well as NP. So array 1 is equivalent to NP dot array. So 1 comma 2 comma 3. So I have taken the element of the 1D array. So you can print that the array 1. So what is the output of this function? 1, 2 and 3. So like that you can print the 2D array and 3D array also. So this is called it as a 1D array. So now 2D array you can copy it as a 2 array format. So 1, 2, 3 and 4, 5, 6, and you can print the function of the output is print array 2 means 1, 2, 3 and 4, 5, 6. So create the 3D array means 1, 2, 3, 4, 5, 6, 7, 8. So like that you can create the function of the 1D array, 2D array and 3D array concept. So the next one is a continuation of the multi-dimensional ND array in NumPy. So 1D array, 2D array, 3D array. So n dimension array is a efficient store the manipulation of the multi-dimensional data. Okay, so the core data structure you are going to sort out is called it as a ND array. Okay, so ND array stands for n dimensional array. Okay, it can be 1D, 2D and 3D, even higher dimensional array also you can use. In Python list, ND array supports bacteria and the operations of broadcasting, which making the numerical computation moves faster. So 1D array we can see the example of 10, 20, 30. 2D array is 1, 2, 3, 4, 5, 6 and 3D array 1, 2, 3, 4, 5, 6, 7, 8. Like this you can create the function of the multi-dimensional of ND array. So next concept of the unit 3 is indexing properties constant. So indexing is nothing but we will see the starting example of the indexing value is 0 and 2 it goes on. Okay, so indexing is nothing but is used to actual individual elements in sequence like list, full strings or NumPy array. My list is equal to 10, 20, 30. Print my list 0. So 0 is my index value, means so output is a 10. So this is the first element of going to indexing the property of the function NumPy. So negative indexing means you can start the -1 value. So negative index will start from the last element of the value. Okay, so they have given the function here, print my list -1. So what is the output of the function is 30. So why? Because coming to the part of the my list here, so my list they have given the 10, 20, 30, right? So -1 they have given the last index value. Negative index value means that is a value you can start function of the negative index means -1. So -1 node value is 30. Okay, so 30 is the last value of you find out the function. So like that you have to comparatively to do the positive index and negative index. So next one, NumPy indexing 2D array they have given. So 2D array they have given the example, you can can import the numpy and as well as 2D function also they have given 1 2 3 4 5 6. So print the array 1 2. So what is the output of the value is 6. Okay, so the better syntax of using this function, so like that you have to do the example here. So what is the Python constant? So constant is nothing but does not enforce true constant but variable written in all caps. So treated the constant by the conversion. So from numpy import pi, so print pi value here. So what is the pi value? Oh, normally you know what is the pi value, 3.141. So that you are going to print as a constant. One number is a constant now, that will not be changed. That is a constant value will be executed as a value. So the pi they have given the example. So they are printing the pi value here. So pi normally what is the pi value here? 3.141. So they are print the output as a 3.141. So these are the constant of the example. And then indexing property. So indexing property is a positive index and negative index. The two examples are given in the function. Okay. So the next topic of the unit 3 is data virtualization. So data virtualization means you can use a graphical representation. Okay. So the data virtualization is a graphical representation of information and data. In Python, it helps us understand trends, patterns, and outline using charts and graph. So charts and graph representation, you're going to virtual the data models and data frames and series and all. So that is called it as a data visualization. So NumPy product, how you are going to create the virtual means numerical operation. So library you're going to install in Python for the data virtualization means matplotlib, seaborn, and then plotly and pandas. Okay, so the most important libraries are going to use in the data visualization. So first example they have given of the import numpy as NP. So NP array 1 2 3. So 2, that is a 1D array. So 2D array 1 2 3 4. So zeros means 2s and 3. That means 2 into 3 matrix you can perform the 0 functions here. So 3 into 3 matrix you can perform the ones function here. What is the range of values? 0s, 10s and 20. And then what is the space numbers of insiding the line space? All those things comes under one examples of using the data virtualization function.